third language, which consists of all possible strings of A's and B's, starting with the substring AAB. That is, possible strings in this language are AAB. So first you may have AAB, and after that you may have any number of A's and B's. So how to construct DFSM for this language? So first step is, the first string in this language is AAB, as we have designed for having a substring ending with AAB. So here also we'll first design for the string A, B reaching the final state 0, 1, 2, 3. So next is, we have to satisfy the language and complete the DFSM. Starting with state Q0. Transition A going to state 1. Next is for B. Can I take a self loop? So let us see what happens if I take a self loop. So if I take a self loop, then the string will start with a B, not with AAB. So the self loop will violate this language. So what to do? We can't take self loop. If I take the transition to state 1, now what happens? It must start with AAB, but you will end up with starting with BAB, which violates the language. So this is also not possible. So what if I take this transition to state 2? So what will be the possible string accepted? Starting with initial state 0, BB reaches the final state, whereas BB doesn't belong to this particular language. So this transition also doesn't satisfy. Then last option, let us try that also. From initial state to state 0 to state 3, transition B. What happens here? Suppose to accept a string AAB, but end up with one single B reaching the final state, which violates the language. So transition B from Q0 can neither go as a self loop, nor to state 1, nor to state 2, or to state 3. Then what to do? At that time comes a state called as trap state, or dead state, or error state, state D, wherein this B transition will be trapped to this state. This state is called as trap state or dead state, as it will be having incoming transitions to it, but it will not have any outgoing transitions to any other states other than the dead state or error state or trap state. So now from state 0, one transition going to, for input symbol A going to state 1, B going to dead state. So going to the next state 1, A we have What about B? Can I take a self loop? Take a self loop and check. Is it possible? Will it be correct? A, B. Instead, A, B, A, B violates this language. So, again, I cannot take self loop for. So, what to do? Go for using the trap state from one transition B going to dead state. Next, from 2 transition for input symbol B reaches state 3. What about A? So A also must be again trapped to dead state. State 2 is over. Next, coming to state 3. Can I have a self loop of A and B to state 3? Let us see. Self loop A comma B. Will it be correct? Just check. Starts with A, B, and after that I may have all possible strings of A's and B's. Then having a self loop to the final state is correct according to the language. So state 0 we have balance, state 1 we have 2 transitions, state 2 we have 2 transitions, state 3 we have 2 transitions. Similarly for dead state or error state also we'll have a self loop to balance the transition. So this is the DFSM for all the strings of A's and B's starting with a substring A, B. As we discussed, an error state or a trap state or a dead state is a rejecting state from which the string can never go back to an accepting state. So in this lecture, we discussed the definition of DFSM. We designed 3 simple DFSMs. We'll discuss some more designs of DFSM in the next lecture. Thank you.